All right, so welcome back. So I'm going to go over this test on basically lines and linear systems. And there's several questions that you will have. I do encourage you to try the test on your own. So I'm going to put a link down below in the show notes so you can open it up, download it for yourself, and then try the test and then come back and try to see what the solutions were, all right, which I'm going to do shortly. Now, this particular topic is a super useful topic, so understanding lines, how to graph them, how to find slopes, how to find intercepts, if lines are perpendicular, parallel, how to solve linear systems with two unknowns is kind of neat to know. All right, and that's exactly what this test is. I'm going to put a general link, okay, so kind of up above with regards to understanding lines, and then that will take you to the various other videos, okay, if you need to understand and refresh yourselves on the topic. Okay, so let's begin. So question number one, place the line. So here is our line, so let me write it out. So we have 3x minus 4y minus 9 is equal to 0. So this particular line is in the standard form. Okay, so if you may remember, so the standard form is ax plus by, okay, plus c is equal to 0. So this definitely looks like that. So let's try to put it in the slope intercept form. So we can do that because that's the first thing that they ask us. And that just simply means we're going to rearrange the formula for y. All right, so let's do that. So I'm going to keep my y on the left-hand side, and I'm going to bring everything over to the right-hand side. So if I do that, I get this. So that's just shifting the two terms over. Now, next, I'm going to divide by -4. So I'm going to do that to both sides. So I'm going to get y is equal to, so this is 3 over 4x minus 9 over 4. All right. And now it is in the slope y-intercept form. So there you have it, okay? So that's the first part. The second part, they ask us identify the slope, the x-intercept, and the y-intercept. So let's do that next. Well, finding these slopes when you have it in this form is rather simple, okay? Because our slope is right here. And then finding our y-intercept, at least, is also simple. Because our y-intercept is right here. Now don't forget the negative. So that would be negative 9 over 4. So those are the two things. Now the x-intercept, it's not very easy to tell right from the equation, but you may remember that the x-intercept is just where the line crosses the x-axis. And that happens when y is equal to 0. So we can substitute y is equal to 0. So I'm going to rewrite that original equation there. So 3x minus 4y minus 9 is equal to 0. So if I substitute y is equal to 0 here, then, well, then that term cancels. And all I have left is 3x minus 9 is equal to 0. So now solving for x. All right, so solving this for x. This is going to be 3x is equal to 9 as that shifts over. Divide by 3 on both sides. And this is your x-intercept. So my x-intercept is 3. Now, sometimes, you know, your teachers may want this as a point. So please don't forget that the y-intercept is the point where it's 0 at x. Okay, and then your x-intercept here. So that would be 3. 0 if they wanted an actual point itself, because that's exactly where it intercepts. All right, so that solves our kind of second part. So we've solved all of that. Now graphing the line. Well, graphing the line, I always really like graphing directly from this, okay, so from the y and intercept form. So I can go ahead and do that. Now I'm going to sketch it for you, okay, within here. So let me just sketch. So this rather quickly, hold on. So the first thing is I'm going to graph. So this is negative 9 over 4. Now, if you have a grid, of course, you can kind of use the grid to your advantage. So now I know that negative 9 over 4, so that is 2 1/4. right? So it's -2¼ because 4 goes into 9 2 times, and then you have a quarter left. So it's going to be somewhere over here. So I'm going to put this right here. So this is -9/4. And now the slope is basically rise over run. Okay, and your rise over run, so you're rising 3, okay, up and then running for 4. All right, so rise over run, so don't forget. So your slope, rise over run, and in this case it is 3/4. So here, okay, so we are running and rising, so this, you know, it could be 4, and then this, okay, it could be 3. Now I already also know the X-intercept, okay, so here right there, so that's kind of nice because this is going to be 3 for my X-intercept, and I can go ahead and draw the line. So let me try it here. All right, and make sure that it goes through those. All right, so it's a positive slope, and there you have it. Okay, so that's what you would actually have for this one. If you have a grid, again, you can use it to your advantage to actually make this much simpler. Now, because we did have the X and the Y intercepts, in reality, all we really had to do is just graph these 2 points, right? So once you graph the 2 points, you just draw a line through that. So that would have been example number 1. And depending on your teacher, you know, sometimes they want this, okay, and then they want you to label this line, you know, so just label it, okay, and write it out so that you get all your points if necessary. All right, okay, so thumbs up to that. Hopefully you got this question right. It was quite a lot of work in this one, so that was question number 1. Okay, so question number 2, let's see what they ask us here. So for the line relation, so we have 2x is equal to -12 and y minus 10 is equal to 0. Identify the slope, x-intercept, and y-intercepts, and graph the lines. All right, so these actually are kind of 2 special lines. And this is really just testing your understanding of both horizontal and vertical lines. All right, so I'm going to isolate these. So notice if you take 2x is equal to -12, I can isolate this for x. So this is x is equal to -6, because if I divide by 2. And then my other line, so this line, y minus 10 is equal to 0. If I isolate this, I'm going to get y is equal to 10. So these are just horizontal and vertical lines, all right? And, you know, so for that kind of question, let me kind of divide this maybe in half here. And we'll work with x is equal to -6 here, and then y is equal to 10 on the opposite side. All right, and then I can graph them on the same space if necessary. So what is the slope, right? I mean, if x is equal to -6, so you may, you know, kind of remember. So if I draw this kind of line for myself, or sorry, this graph for myself right here. So x equal to -6, so basically what we have is, we have a line which is going straight up, okay, so in this, let me move this on the -6 there. So that is our line. So what's the slope? Okay, do you remember what the slope of vertical lines is? Well, the slope is undefined. It's kind of an infinite slope. It goes straight up. Okay, so we have a slope that is undefined. So our slope in this case is undefined. All right, so that's the first part. Now the x-intercept, well, the x-intercept is easy because it goes right through -6. So this goes through -6, so it is the point of -6, 0, if you want to be specific. And then the y-intercept, so I know that sometimes teachers like to ask this, there is no y-intercept. It's actually parallel to the y-axis. So there is no y-intercept, all right? So that's what you would have there. So that's for that line. Now, what about y is equal to 10? I will kind of cheat and use the same graph here. Let's put 10 over here. And what you have your line, okay, which basically, and again, this one will go straight, whoops, okay, we'll go straight through the 10 right there. So it's a flat line, right? So now what do we know about flat lines? That the slope is 0. So that's what we know there. Okay, what do we know about the x-intercept? Well, in this case, there is no x-intercept. So here, so there is no x-intercept because it is parallel to the x-axis. All right. And then finally, your y-intercept, well, in this case, it is 10, or, if you want to be specific, okay, so that's what that point would be. And that's, okay, actually everything that they asked in this question. And we've also graphed it as well. All right, so those are the graphs. So that's a great question and really tests you on understanding horizontal and vertical lines. All right, so next question. So question number 3. So identify if the pair of relations are parallel, perpendicular, or neither. So whenever you get asked this, obviously you have to know what makes lines parallel or perpendicular. So if you recall, parallel lines have the same slope, right? So they will have the same exact slope and they never meet. So they're basically kind of two lines going in parallel in this direction, vertical, whatever, okay? But they never meet. So they will have the same kind of a slope. Perpendicular means that they're basically intersecting at a 90-degree angle, all right? So this here, they're intersecting at an angle of 90 degrees. And neither obviously means that they're not perpendicular or they're not parallel. So they're just intersecting at some point. So let's take a look at the examples that they gave us, all right? And then we're going to try to see. Now, probably the easiest thing to do is to check if they're parallel or perpendicular is to actually first get the slope, right? That's the first thing that we have. And then go from there. So I'm going to take the first example, so this one right here. Let me work with this example. So I have y is equal to 3x minus 5. And now my second line is actually in its standard form. So I'm going to kind of rearrange it for y. So let me isolate it for y. So what I will get there is, so I have negative y, I'm going to bring the other terms over and then divide it or multiply by negative 1. So this is going to be that. So notice my two lines, so this is my first line and then this is my second line. And notice that they have exactly the same slope. All right. So in this particular case, they have the exact same slope. They have different y-intercepts, okay, and the slope is 3. So one is intersecting at negative 5 and then the other one at 8. So they're quite a bit apart, but because they have the same slope, then these two lines are parallel. So if you had to explain, so you would actually have to write here for your teacher or whoever might be marking this, you would have to say that they are parallel because they have the exact same slope, but they have a different y-intercept, all right? So that would be for part A. Now for part B, so for our next one, so this one, luckily, I'll change color. So this one is actually already in the nice y-intercept form here. Now clearly the slopes are not the same, so this is not going to be parallel, so it's either perpendicular or neither. Now I don't know if you remember, but when you're testing perpendicular lines, what you have, the easiest test to do, instead of graphing and trying to figure out visually, is just to try to see if the slopes are negative reciprocals of each other, all right? And what that means, you can kind of test it in two things. You can take the slopes, all right, so of line number 1, okay, and multiply it by the slope of line number 2. So in this case, it would have been negative 2 multiplied by 1/2. And when you multiply, actually I see that already, if your product is equal to negative 1, that means the lines are perpendicular. Okay, so in this case, these two lines are perpendicular. Or you can just look at the actual slope, take the negative reciprocal, and then see if you get the other slope back. So for instance, if I take -2, so -2, the negative reciprocal of that is basically a half. Negative means you multiply by negative, so that gets rid of the negative. And then taking the reciprocal of 2 is swapping it, so it would be 1/2. So that's another test that you can check. So indeed, these two lines are perpendicular. And then so here, this would have been your explanation. Or you could have just explained it, said that the negative reciprocals are equal. All right, so that would have been for B. Now for C, these are actually kind of related back to the previous question. So notice x is equal to -1, so that's a vertical line. And then y is equal to 3, that's actually a horizontal line. So these ones, okay, the way that they are actually perpendicular. And notice, excuse me, the slopes, okay, so the slope test, you kind of have to be careful a little bit. So this one is more of an intuition, because the slope of a vertical line that you have is undefined, right? It's a number over 0. And if you take the reciprocal, negative reciprocal, you're actually going to get 0, which is the slope of your vertical line. All right, but these two lines, okay, so what you have, okay, is you have a line which goes straight up, that is x equal to -1, and then you have a line which goes, okay, in this way, and that is your y is equal to 3. And notice they indeed are just they're 90 degrees, okay, in between in terms of the angle. All right, so this is a great one, and maybe a little bit more, so don't, just so that you can see it for yourself. So this has an undefined slope. So now an undefined slope is some number over 0, right? And as I say, if you want to take the negative reciprocal to check, well, it's going to be 0 over n, right? If you take the negative of that, it's still 0 over n, but 0 over some number is just 0, which is the slope of a flat line. All right, so that's another explanation, but I'm not sure if people would actually get that one or not. Okay, so this is a great question, and so that you can have and it will test your ability. Okay, so next example. Find the equation of the line going through the 2 points. All right, and leave it in your slope-intercept form. All right, so sounds good. So we have 2 points. So what do we do and how do we find our lines, okay, in these situations? So this is a great one, and sometimes it gives people headaches. Okay, so let's try them. So I'm going to first try A. So what do we need? Well, we need a slope, right? And then we need our y-intercept. So we need those two things. Our slope is equal to, so you may recall, so this is y2 minus y1. So it's our rise over run, x2 minus x1. And in this case so this is 0.1, this is 0.2. So I'm going to have, okay, so this is 4 minus 3. That's my y values all over. 3 minus -1. So that's going to be 1 all over. And 3 minus -1, so that is actually 4. All right, so this is 1 over 4. So that's my slope of the first line. So what I have so far, so this is y is equal to 1 over 4x plus b, right? So now I'm going to try to find b. Now, how do we find b? Is you just pick any of the points, because the line has to run through it, and substitute it. So let's say I'm going to pick, all right, so point number 1, so this one, and I'm going to substitute it. So if I substitute this in, so -1 over 3 into my line, I will get 3 is equal to, so 1 over 4, -1 plus b. And now you can solve for b. So this will be 3 is equal to negative 1 over 4 plus b. All right, so let me put that there. I can bring the negative 1 over 4 over on the other side. So I'm going to get 3 plus 1 over 4 is equal to b. So this is basically 3 1/4. That's your b. Now we don't really write a mixed number in there, so you can change this back into improper fraction if you like. All right, so this one, so 4 times 3 is 12 plus the 1. So that would be 13 over 4, and that's your b. Okay, so our first line, okay, it is 1 over 4x plus 13 over 4. So that is our first equation of the line. All right. Now I'm going to cheat a little bit. You know, I know that you guys would have still another page here. Okay, so to try to do it, I can kind of cheat. Let me kind of copy this down. And I'm going to do the second. And I'm going to just switch colors here just so that it stands out from the other one. So this is for line number B. All right. Oh, so this is great because one of the points, notice it says 0 and negative 2. So if that's the point, then 0, negative 2 is actually your y-intercept. So this is going to be much easier. Okay, because that's one of the conditions you need, right? Y-intercept, it's where your line crosses the y-axis, and that happens when x is equal to 0. Okay, so that's what we have there. Okay, so let's try it. Okay, and let's try to see what happens here. Okay, so my slope, so this is going to be 3 minus negative 2, so all over. All right, and this is going to be negative 2 minus 0. So my slope is actually what, 5 over negative 2. So this is negative 5 over 2. Okay, so that's what we have there. So that's our slope, and we just said that our y-intercept is negative 2. Okay, and that's coming from the point itself. So our second equation of the line is this. All right, and that's what you have there, and that completes, okay, so this example. So we have our two lines that we needed. Let's move on. Okay, so now next one. So here it states, for each line, identify the slope, the y-intercept, the x-intercept, and then write equation in standard form. All right, so standard form. So it's going to be a little bit annoying, but we will do it. Okay, so we have a vertical line. Okay, so that one is going to be a little bit easier to tackle. And then we have a line, which is the blue line. Okay, that goes both through the x and the y axis. Okay, so that one has some positive slope. Okay, so let's try it. So identifying the slope. So if I take the first line, so the blue one, so again, remember the slope, so I'm gonna, so this is, I have kind of my intercepts there that you see, so I can actually pick off the intercepts right away. So notice that so for line number 1, the y-intercept and then the x-intercept, so that is, so y-intercept is negative 4, okay, so negative 4, or as a point it would be 0, negative 4. And then your x-intercept, it's 3, so that would be 3, 0, all right, as a point. And my slope that I actually have, so my slope, so notice again, rise over run. So my rise, 1, 2, 3, 4, that's my rise. And then 1, 2, 3, that's my run. All right, so my equation is y is equal to 4 over 3x, and then y-intercept was negative 4. that is in the slope y-intercept form. Now they want it in standard form. All right, so if they want it in standard form, so we're going to try to shift everything out. Now I don't like having a standard form with fractions. I just like to have the coefficients as being integers, right, or whole numbers. So what I'm going to do is I'm going to multiply this entire thing by 3 so that I get rid of that 3 in the denominator. So that's going to be, so I'm going to multiply the left hand side, so that's 3y, and then my right hand side, then it's going to be 4x minus, and 4 times 3 is 12, all right? And now I'm going to shift the 4x and the negative 12 on the opposite side. So I'm going to get negative 4x plus 3y plus 12 is equal to 0. So we're almost there. If you recall, standard form, we do not like to have a negative, all right, for our leading a in front of the x. So in order to do that, we just multiply it by negative 1. So that's going to be 4x minus 3y minus 12 is equal to 0. Okay, so you just multiply every single coefficient by negative 1. And that is your standard form. All right. Now for your second one, this one is going to be much, much easier. Because it's a vertical line, notice we only have an x-intercept in here, which is actually negative 5. So if you write this out, maybe I'll write it here on the side. So y-intercept, okay, so there is none. It doesn't go through it. Your x-intercept, it is negative 5. So it is the point negative 5, 0. The slope, m, is undefined, right? So it is n over 0, right? Which is undefined. It's a vertical line. So therefore, our equation of the line, in this case, is simply just x is equal to negative 5. Now, if you want this in standard form, then all you're going to do is you're going to bring the negative 5 over on the other side. So it's going to be x plus 5 is equal to 0. Okay, so and that's all you have. Y doesn't have a coefficient. That's why the y is not there. And that's it. All right, so that would have been this example. So another great question. I hope you were able to get it. All right, so now, and it looks like this is the last example, last question on this test, and it says solve the following linear systems. All right, so we have two parts, so part A and part B, okay, and we're supposed to solve this. So basically, you know, how are these two lines intersecting? Because that's what solutions to linear systems are. So do they intersect in a point? All right, is it a line, or do they never intersect? So let's take a look and see. So I'm going to first do part A. Maybe let me switch this. So I have 4x minus y is equal to 2, and y is equal to negative x plus 5. So if you kind of gone over these linear systems, okay, and I did do a video on how to solve these. Actually, it was a pretty lengthy video with a lot of examples, so you can look at that. I guess I can put a link up above there to that one if you want to see it. So what I like to do is, I mean, since I right away see that I have y is equal to negative x plus 5, I'm going to substitute this back into this line, and then I'm going to solve for my x. All right, so let's see what happens. So I have 4x minus, now substitution, so negative x plus 5 equals to 2. Let me get rid of the bracket there. So I'm going to distribute the negative. So this negative is going to get distributed across. So this is what I have. Now grouping my like terms, so that's going to be 5x, and we're going to bring the other 5 over on the other side. So this is 5x plus 7. So notice here, so that would have been my first one. So x is equal to 7 over 5. All right. Now you're not done. You have solved for your x. Remember that this, we're trying to find the actual solution to the point. So this is going to be a point where these two lines intersect somewhere. So now you can take this x and then substitute it back into one of the equations, and then you can choose which equation you want. So I mean, I kind of will choose the easier one because it's already isolated for y, so this is going to be that. Substitute the 7/5, right? So I'm substituting it in there, and then plus the 5. All right, so here, so what you have, so I just want to show you. So you have, so this is negative, I mean it's a fraction, so it's 7/5 plus the 5, all right, and we get y is equal to 18/5. So your solution, okay, to this system, this linear system, is basically this point. And the meaning means that our line our two lines are intersecting at this point. All right, so that would have been example number 1. Okay, now example number 2. So I have, let me maybe copy it down. So this example right here, let me bring it down, make it bigger. So let's take a look and see. So I have 2x plus 4y minus 1 equals to 0, and then I have 6x plus 12y plus 4 is equal to 0. So for this example, so again, you can isolate for y and then substitute it back into the other equation. I'm actually, for that, I actually can see, notice that the coefficients, so there's 2 and the 4, and then the 6 and the 12. Okay, so one nice way of seeing that the coefficients, they look like they are just 3 times bigger in the second one. Notice if I multiply 2 by 3, I'm going to get 6. And if I multiply 4 by 3, I'm going to get 12. Now, the 1 multiplied by 3 is not going to give me 4. So these are not the same lines, right? So something is going to happen here, all right? So we will see that something interesting should happen. So this is probably just parallel lines. So let's take a look and see. So I'm going to isolate this, okay, for y. So this is 4y is equal to, let me bring those over on the other side. This is going to be y, and then divided by 4. So it's going to be negative 2/4x plus 1/4. Now this is just negative 1/2 x. So that's, I'm just reducing that fraction there. So that's my first line. And as I said, you can take that and substitute it back into the equation and then see what happens. All right? Okay, so that's one way, okay, of trying to see it. So I'm going to do that, although I do see that probably these are kind of parallel lines, so they may not intersect at all. So let me substitute it back in here. So this is going to be 6x plus 12. Now substituting, so negative 1/2 x plus 1/4 plus 4 is equal to 0. So now we want to solve for x. But I already see, because I'm going to distribute and factor this in, so that's going to be negative. Now 12 times 1/2 is basically, so this is your 6, and 12 times 1/4, so that's going to be 3, plus 4 is equal to 0. And notice what happens. 6x minus 6x is 0x, right? This is plus 7, 0. So really, if I bring that 7 over on the other side, I'm going to get this. All right? And what this tells me, okay, so in terms of when you were practicing and going over solving equations, right? So when you were solving equations, this was a special case in solving equations. And when you get this, because there is no solution here, so notice, it doesn't matter what we plug in for x. we're always going to get 0 on the left-hand side. And 0 is never going to be equal to -7. So this has actually no solution. And I encourage you to see that these will be actually parallel lines. So if you isolated the second equation for y, you would find that it has exactly the same slope, but a different y-intercept, and therefore they never meet. And that's what this is telling us. And that's it for this test. So I wonder how well you did. Super hard questions actually on this one, but they definitely do test your ability if you understand quite a bit about lines, standard form y is equal to mx+b form, parallel lines, perpendicular lines, as you can see, you know, systems of equations. Okay, so these ones were great. Okay, so thanks for watching. All right, we'll see you in a future video.